Hello, ladies and gentlemen. I'm pleased to be here. One reason is we had only 2 degrees this morning in Germany, so 2 degrees more than the English one, but that's not the main reason. The main reason for me is that it's, on account of my long years of contact, a pleasure to show this new development on a European level in the biowaste sector, which is the so-called end-of-waste standard. First, I'd like to introduce myself. I'm Joseph Barth, the Managing Director of a compost consultant company, Informa. I was with the European Compost Network until January this year. This is a very big European-wide organization where all organizations and experts are working together, which work on biowaste. For example, the Italian CIC Compost Association is a member in the European Compost Network too. And since 2008, I was dedicated to work on this end-of-waste standard together with the Joint Research Center of the European Commission in Seville. And it's now a pleasure for me to introduce you a little bit to this new development on a European level, which from my perspective is a very, very important one. Here, a quick overview about the situation in Europe. We have a lot of countries with established biowaste policy, including separate collection. In some countries, there is a lot to do, and we expect some fast progress in the next years, mainly because of the European Landfill Directive and the diversion targets which are stated there, and which give a kind of pressure, a kind of driver for the countries which are in the starting position to do more on biowaste. You see, we are probably with the new figures which Dr. Gilbert showed, only at around 1/3 of the potential, so there's still a long way to go. And even in advanced countries like Germany, like Italy, there is still room for some improvement in the next years. When we are looking on the development in the waste sector, we can see that we have some important elements which drive the development. Nothing happens without legislation. So in every country we need a kind of legislative driver, a legislative push, so that the development will start. This legislation guides the industry, guides the investment in the development. This end-of-waste development can play this regulatory push role on a European level because it shows a little bit where the countries have to go. If we have the regulatory push in the recycling sector, we need good recycling products, quality controlled. So in Europe, especially for compost, it is obvious and very good experience, including Italy. We need a quality control, a quality assurance, and that is element of end-of-waste too. So if we have the regulatory push and we have a high-quality product, then the market starts to demand for that product and creates the corresponding pull, and this allows us to go on successfully in closing the organic loop for the recycled organics from our households and gardens. So why this end-of-waste regulation? Dr. Gilbert mentioned it a little bit. We have compost and digestate on a European level, but even the Commission detected we can do more in this sector, so they are underused material. We can produce more and we can use more, and this should contribute to one of the main topics for the next years by the European Commission's policy, which is resource management, resource efficiency. So we are no longer talking about waste, we only talk about resources. One important aspect the Commission detected by talking about recycling, we need high quality recycling products, and we need the confidence of those who use these recycled products that these products are good, okay, and comparable to primary products. Especially in the compost area, you all know, that it is very important that there is confidence in the quality of compost, otherwise no one will buy it. So this was detected by the European Commission, and they see, therefore, they have to establish standards, and only with the standards they have a product which can be qualified, which can be described, which has specification, and when it's clear what the properties are, then it can be marketed on a large scale all over Europe. So these preconditions can be summarized within the idea of end of waste, and therefore the Waste Framework Directive require this end of waste besides other materials, especially for compost, and this is the reason why we are now at this point. So the main purpose for this end of waste criteria is that we should do more recycling in order to save our resources. We should have a legal certainty with this recycling and the recycled products. And in addition, the idea was to remove unnecessary administrative burdens when we establish compost on the market as a product, when we produce this compost. I would like to make a little bit a question mark behind this unnecessary administrative burdens. I hope that we will not have additional burdens for the compost sector. Few other sectors, for example, glass, they are suffering a little bit on account of additional administrative burdens. So, if this end of waste purpose is met, and everything is controlled, is under regulatory control, then we have this end of waste status, which means we have a product which is no longer waste. It sounds quite simple, but it's on a European level not that simple. If we have a product standard on a European level, this product standard is valid in every country. You cannot say, as Italy, we don't accept these products. You have to accept compost if it is qualified on a European level as products, and you have to accept the quality criteria, which means end of waste will affect all the national legislation. The idea of a European product is it should be sold on a European market, and if it is sold, then it has to be safe, which is, if you sell a fridge, quite easy, but if you sell compost, for example, from Spain to Sweden, it's not that easy. So the selling and the transport and the characterization of the product has to be safe. It should be something with a low risk. It happened in Germany that we got some compost coming from Spain over a few other countries, and it polluted the soil over 60 hectares in the water protection area. It was very complicated to trace back where the material is coming, where the material came, and this should be avoided by these requirements of safety for a European product. Therefore, end of waste will only qualify high-quality products, where the risk is low and where the safety is given. So this is a key principle. It is valid in all European countries, and it is of high quality in order to reduce the risk when it is sold over borders. Okay, a little bit history about the end of waste development. The main activities started in February. The consultation ended 2 months ago in January, and now the Joint Research Center of the Commission is preparing the final report, which should be finalized until June, July this month. Then it goes to the EU regulation activities, which is a comitology procedure, and we will expect beginning next year to have this end of waste regulation in place. What is new since end of last year, beginning of this year, is that it's not only compost, which is the idea, what was the idea of the beginning. Now digestate are fully included. So the regulation is not only for compost, it's for the outcome of the digestion process in addition. Okay. The key elements are very important, a positive list. Yeah? Okay, we can say if we want to have a safe material, let's just look on the heavy metal threshold. Yeah? But this is not all when it comes to safety. You don't control the compost every day. So you need a kind of security, and the security is supported by measurements of heavy metal thresholds. And in order to get a high-quality product, you need clean and good input material. Therefore, this input material, this positive list, is so important. The next important element are thresholds, limit values, and the third element is that we have a very, very good declaration of the quality and of the properties of the product, so that everyone in Europe can see these are the products, properties, and I can use it for this and for that purpose, and it's of good quality. All have to be assured by an external independent third-party control. This is a standard, and it's mainly done by a quality assurance scheme like you have it in Italy, like we have it in other European countries too. Let's have a short review on the criteria. We have the same criteria more or less for compost and digestate. We have slightly higher heavy metal thresholds than in the past for zinc and for copper. These can be seen as a kind of trace nutrients, and mainly because of digestate, these values have to be increased. For example, in Germany we had 110 in 400, and because of this digestate, it has to be improved. The zinc and copper contents in digestate are mainly coming from the feeding stuff for the animals. Yeah? Okay, so these are the thresholds on which you will be affected in Italy in the future. As far as I know, it's not a big problem, but it will be valid on a European level when it comes to a compost product, an end-of-waste product. We have this end-of-waste product, and as it already mentioned, in parallel we have the fertilizer regulation, where organic fertilizer is included. So the cross-reference is we need standard and a control for the organic fertilizer in the fertilizer regulations like we have it for end-of-waste. And it will be not feasible to develop two systems on a European level. So we can be quite sure that we will have the same requirements and the same control activities in the back for both legal developments on a European level, the fertilizer regulation and for the end-of-waste standards. Okay, these are the developments for the moment on end-of-waste. We are in the final stage of the development of the methodology and the criteria. Nevertheless, we can already see a certain effect in some European countries coming from this draft. End-of-waste as a whole is a very important tool in European bio-waste management. We urgently need it. Dr. Gilbert talked about another legislation, working paper second draft from 2001. It was more or less quite similar to what we can expect now from end-of-waste. So we needed more than 10 years to come to a real conclusion in getting for a next step to have a quality idea in Europe. And that is, from my perspective, the main outcome of this end-of-waste procedure. The European Commission says, okay, we have end-of-waste. This opens a European market for compost. How many tons of compost will be exported from Italy to another country? It's marginal. So the only area where some compost crosses the border is between the Netherlands and Germany. In all the other countries, it's I think less than 1% in Europe. So this is not the real benefit of end of waste. But we have what we required since years from the Commission. We have now on a European level a definition what is compost quality. Before this end of waste, no one had an idea what it is. Every country has his own definition, and now we have it on a European level. And this is the main benefit, and this is very important because this will affect legislation, this will affect technology, this will affect compost production and even separate collection. Yeah? So this is much more relevant than something transporting something over borders in the framework of a European market. This new legislation has to be adopted. We see it in some countries, for example, Portugal had a discussion on revising the national waste management plan, which recently started. The original plan was going for MPT and use the brown material on agricultural land, use the high calorific RDF, refuse-derived fuels, in cement kilns and get a lot of energy, and the little bit rest should go to landfill. So the idea was this could solve all the problems. Now, when we have a European definition of compost quality, we will see that the customers, for example, the agricultural market, will ask for this quality. And this will be a European idea of quality. And therefore, the agricultural sector all over Europe, when it comes to food production, will ask for end-of-waste standards. And this will require, because the market is then missing, that the countries have to revise the organic waste strategy and have to go to superior developments when it comes to quality. Yeah? So the market will react and will demand this end-of-waste quality, and first of all, where we will produce the food. You know? One aspect, products are normally subject to the chemicals guideline REACH. Compost is exempted because it's a natural substance. Digestate is for the moment not. We will work on that so that digestate might be in future exempted from REACH. We will see what is the outcome. Okay, this was a short review on the end-of-waste situation and the end-of-waste development in Europe. Italy, like all the other European countries, will be affected. Not that much, because you are already producing high-quality compost products. Nevertheless, this legislation and this situation has to be adapted to the Italian market. And for me, it's quite important, because since I'm in the compost business, I'm focused on quality, 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 because I learned this is the key for all what we are doing in the organic waste recycling sector. Thank you very much.
Grazie anche per questo contributo, anche questo da discutere. E il prossimo speaker è l'ingegnere Davide Mainero, che appartiene sempre al working group sul biological treatment di ISVA e che parlerà anche dell'esperienza, credo, specifica del territorio piemontese. Il suo titolo è Compostaggio di gestione anaerobica, una rassegna di trend ed approcci.
So, thank you, Chairman, ladies and gentlemen. I'm not Danish. Unfortunately, Mr. Brogger is not here, has not been able to be here, so I try to substitute him with this talk. And I want to acknowledge Alberto Confalonieri from the Scuola Agraria del Parco di Monza, who gave me a deep help on this PowerPoint presentation. This is my agenda. I will speak about drivers that has already been touched by Jane, much more deep than me. And then I will focus on the integration of anaerobic digestion and composting, giving some data on the trends in Europe, and much more focus on Italy, not so on Piedmont. And then I will go to my conclusions. So if we move to drivers, has already been told that we are waiting from several years from a Biowaste directive. I have put here a statement that it's it was a very interesting and perspective one from the Council conclusion of a green paper on the management of biowaste in the European Union on June 2009. But we don't have any biowaste directive. What we will have soon is the end of waste criteria, as Joseph Bart had told before. And still, we don't have a soil framework directive, as told Enzo before. The peat or the consideration of peat is something that is beneath the soil framework directive, and the idea that if we don't dig peat, we still have a carbon sink, so we don't have to move carbon from one area that has already been stored. In the end, our legal framework is based on the landfill directive. Another important legs, as we can say, is the target for the 2020, and so the perspective of the sustainability. What happened right now in Europe? If we consider the effect of the landfill directive, we see that we have a reduction of waste to landfill from 1995 to 2009, from the average from 296 kilo per inhabitant to 195 per capita, as well an increment of percentage treated by composting and mechanical biological treatment. And here Italy plays an important role as well. Austria is still one of the best. And this is important to underline, and here is important to underline that the quality of the material, so good organic fractions, deeply affect the way how we recover, as well as Jane has underlined, the eco-taxes drives very well the market. If we see the perspective on energetic point of view, these are from some data from the last Europe survey on biogas. Of course, under other biogas, there are not only biogas produced by AD, so biowaste, but also landfill gas and so on. But it's interesting to underline that we have had a really strong increase from in 1 year of 31%. And there is a very deep interest in some country on biogas as an energetic vector, let's say biomethane. So this is much more true in Germany, Sweden, and the Netherlands right now. This is data still from Europe survey that gives an idea of how the European country, I think it's 27 here, 27 EU country, will reach the National Renewable Energy Plan in 2020 on the biogas target, at least quite easily here. So maybe we have to enlarge the target, or I don't know. Why we should choose aerobic and anaerobic? Well, I have just put here some statements that probably are quite common and known from everybody, but okay, the two processes are natural one. Composting turns organic matter into stable humus and develops excess heat and release carbon dioxide. As well, anaerobic digestion develops methane and don't produce heat as composting does. Anaerobic digestion process had to be kept completely isolated. We can have wet or dry and so on. We will see later. And I think that's important to underline that strictly anaerobic condition is much easily achieved in fluids, but we can open the discussion on that. In the end, why we should? Because we can make the solution much more flexible and robust, even by an economical point of view. Of course, organic waste is not uniform, so we have to take care of impurities. And let's say that under the so-called solid organic has a lot of it grow acid and create a feedstock for AD, as well as lignite that doesn't produce AD. doesn't produce biogas in a AD process. And also, much more, because no organics can be totally turned into either biogas or compost. What is the situation around in Europe? These are data from the technical committee of the Italian Composting Association. Data are at 2010. So 16 nations. We have 202 operating plants. Most of them are operating with the organic fraction of municipally solid waste. And the total capacity treated in 2010 is roughly 10 million tons. This is the distribution. It's just by capacity, so it's not weighted for the people, and that's why we can see that there are a very spread distribution between several countries. Of course, Germany plays the most important role. It's interesting, Spain, but much more data on Spain are from Catalonia in the end. And if we consider the anaerobic digestion under different point of view, so the temperature or the way we treat the waste, let's say wet, semi-dry or dry, considering wet beneath 10% of total solid and semi-dry between 10 and 20 and dry above 20, we can divide the number, the figures that we have on 202 plants like in this table. And we can see that much of the plant, well, half of the plant are in a wet condition, as well as, they can divide it between mesophilic and thermophilic. It's not really a trend that it's gaining one above the other. There are some data that are not classified as well, the condition, and can be both mesophilic and thermophilic. This is practically the same data on the table, where I've put down the number of the plants. So we can see that roughly 60 plants for thermophilic as mesophilic are there. Mostly of the percentage is by organic fraction of municipally solid waste, so source-separated bio-waste. If we come to Italy, just first of all, we have to fix where is the amount of waste that we treat. And during the last 4 years, practically Italy has stabilized the production of waste. So we have around 32 million tons. And this is treated, if we come to organic fraction municipally solid waste, basically it's still a percentage that has increased during the years. We have a separate collection that has other constant increase since 2004, as well the fact that the separate collection target has been enforced, and even in the 2012 revised Italian waste framework direction, they will be still fixed at that level. And this is the table from the perspective on the organic waste treatment for the Italian Composting Association. And as you can see, the perspective is that both the organic fraction as well the so-called green waste is increasing in perspective during the next years. This is what happened between 1993 to 2010. Now we have around 281 plants, and we have treated 3,700,000 tons of waste, divided, as you can see in the table below, where you can see a strong increase in the integration of anaerobic digestion and composting. We have a 30% increase from 2008 to 2009. All this capacity is distributed by ton capacity. We have an interesting data on between green composting and organic fraction release for solid waste. We have small plants that treat only green composting. So we have more than 50% of plants that treat just green waste. If we come to the other side of the table, we can see that more than 50% of the organic fraction municipal solid waste is treated in bigger plant. And this is quite the same if we come to dividing between technology. And much more green composting is in just turned piles. And if we come to organic fraction municipal solid waste, we have much more distribution. So turned piles plays an important role as well, but as well as closed bioreactors. The story of anaerobic digestion in Italy is, let's say, it has a two-step story. We start in the 90s with some historical mechanical biological treatment plant in Cadelbue, close to Verona as well, Villa Cidro and Bassano del Grappa. And then we have a sort of new story in the early 2000s. What happened is that now we have 18 waste treatment plants. They treat roughly 600,000 tons of biowaste. And all plants treat source segregated waste. So even the plant that started with mechanical biological treatment, they moved to the source separated organic fraction. In Italy, the distribution between technology is more separated than in Europe. We have much more wet solution, as well much more mesophilic one than in the distribution that we have seen in Europe. One stage is prevalent, as well continuous feeding of the digester and not batch one. Which are the drivers and limiting factor for integrated plants implementation? Because right now, as you have seen, we have 281 plants for composting and only 18 with anaerobic digestion. So there is a demand from the market to put together this, to integrate this solution. We still have the subsidy for energy, well, till 2012. We don't know what will happen in next year, but this is a strong plus. As well, of course, has already been talked before by Enzo for the carbon dioxide perspective for the biogas potential. Of course, one of the key aspects is the lower odor emissions, a lower need of green waste for the aerobic step, and as well the let's say, lower ecological footprint from compost than composting only. We have also some minus one. We have it's much more intensive under a capital cost. So much more this economy of scale. We have seen the data on the composting, on the distribution in Italy of the ton treated per plant. Much more the organic fraction. The plant who treat organic fraction of municipal solid waste are bigger, so this is a fact that we can see on the market, and it's a minus in a perspective. We have a key and important aspect that is the liquid waste treatment. So ammonia play an important role for for the treating of for changing from composting to anaerobic digestion, and waste purity is very a key aspect of all the stuff. From a survey that has been made from Scuola Agraria del Parco di Monza between 22 composting plants, we have some interesting data that gives an idea of why the operator should change from composting plant, and let's say that. Basically, because they say that they have to state odor problems, high or medium. Of course, they want to probably increase the capacity, but they have a lack of space. As well, the problem with green availability in the plant. The same survey gives us information for a very high interest for anaerobic digestion. This survey probably pays also the fact that has been made in 2010. So at that time we have much more confidence on the electric energy incentive. Now it's probably not so sure, but in the end, it's all the composter sees the perspective as a potential increasing of the treating capacity of the plant. Well, coming to my conclusions, I just underlined that it seems that we can state that the integration of composting and aerobic solution is becoming a general. Sorry. A general approach to the biowaste management in Europe, much more for the flexibility reason, because as we have seen also in Italy, we can evolve from a mechanical and biological treatment to composting and aerobic digestion one. The case of Villa Cidro, it's quite an example as well, the one of Cadelbue in Verona. By the way, based on the same German technology in the beginning. And if we just summarize the plus and the minus, we can see that, okay, the integration gives a quite easy control and other emission compared to the simple solutions. We need less surface compared to the only composting one. And, okay, is a net energy producing process. As well, it gives an higher guarantee on pathogen organism control thanks to the double thermic passage, compared only to composting or only to AD. This is probably a position that is different from the waste perspective on digestate and composting. This is much more specific on Italy. A minus is the waste purity. We need much more waste purity because they affects really the robustness and the amount to react in the production of the plant. We have an interesting perspective with the increment of the use of biodegradable bags that probably will help to tackle this aspect. As well, we cannot consider the ammonia-rich wastewater that we react. But also in perspective, this also could be turned into potential help to the economic of the plant as well, because we could potentially recovering nitrogen. But okay, we have no economical driver to pay fossil product costs right now on the market. At present, we can say that most of the EU countries have only electric energy production incentive schemes. The hope is that the enforcement of the 28 directive will introduce some changes, maybe for biomethane as well in Italy, or not only in Germany and the Netherlands or Sweden, as we have talked before. Also, the digestate management criteria, but we can see that there are, at least in Italy, we have different way they have been treated from different province or local authorities. Thank you very much for your attention.
Grazie, signor Mainero. L'ultimo intervento di questa serie più tecnica sarà quello dell'ingegner Brizio di ARPA Piemonte, che a proposito dei trattamenti biologici parlerà di criticità ambientali a scala regionale.
Thank you, Mr. Chairman. Good afternoon, everybody. In this few slides, we will talk about the environmental shortcomings of renewable energy source and also biological treatments as well at the local scale. Let's start by saying that northern Italy is one of the most polluted areas in the world. As you can see from the satellite, we actually don't comply with the air quality limits for NOx, for ozone, for PM10. And this is due to our orography and, of course, demographic aspects. And we have to remember that just a small part of PM10 that we can measure at the ground level is due to primary particles emitted as particles. Most of particles are secondary, coming from gaseous compounds such as ammonia, such as volatile organic compounds, nitrogen oxide, and so on. So in such a delicate area, any new energy scenario, any new treatment scenario should be carefully assessed in order to reach positive emissive balance by using the best available techniques, by limiting, minimizing emissions, by being energy efficient, by minimizing odors, and so on. And the last crucial environmental aspect is the kind of economic subsidy. The subsidy structure can bring about benefits or environmental impacts or inefficiencies. So the first analysis is anaerobic digestion, and it is based mainly on data collected from anaerobic digestion of manure and energy crops, but the conclusions are valid also for anaerobic digestion of biowaste, sludge, and so on. So the first aspect is ammonia. Anaerobic digestion hydrolyzes organic nitrogen to ammonia. So higher ammonia, higher temperature, higher pH enhances volatilization potential of ammonia from the storage of digested materials, but also the treatment of digested material, the land spreading, and so on. The second point is greenhouse gas emissions. First of all, the post-methanation potential from the storage of digested material, but also nitrous oxides from the storage and aerobic treatment of digested materials. And also greenhouse gas emission from the biogas engine, methane slip, of course. The third point is that thermal energy is often not recovered because of the lack of specific economic drivers. In spite of its big potentiality of compensating new emissions, we can provide it for district heating, for factories, for dryers, and so on. The fourth point is the emission at the local scale from biogas engine, and we will deepen this kind of problem in the next two slides. And finally, the nitrate contamination of wastewater that is widespread, and it is due to intensive farming, and that could get worse because of the inefficient use of digested materials. Digested materials is not a specific fertilizer, it's just material containing nitrogen somehow. So here you can see a comparison between the emissive performances of renewable energy sources, so biomass combustion, vegetable oil combustion, anaerobic digestion, and biogas production, compared to the average Italian power plants, so fossil fuels performances. And as you can see, the specific emission from renewable energy sources are twice, 3 times, up to 10 times larger than fossil fuel, even though best available techniques are sometimes applied. And this is a summary of atmospheric emissions from a 1 megawatt electricity biogas engine within a farming context. You can see that emissions are quite large. Try to imagine the global impact of these emissions from all biogas plants built in the last 3 years in Italy, that are 350 megawatt, is a huge amount of pollutants that are of the same order of magnitude as the emissive reduction due to intervention policies on traffic, intervention policies on civil heating plants, on IPPC factories, cement factories, power plants, and so on. Of course, this kind of emission can be strongly reduced by applying selective catalytic reduction on nitrogen oxide, thermal oxidation on methane slip from the engine, and for volatile organic compounds like formaldehyde, and so on. And the correct operative management of digested materials. But nowadays, the Italian technical regulation are not suitable to minimize, to manage the impact of a massive introduction of this kind of plant. In this sense, the biogas upgrade into biomethane represents a very interesting chance for three main reasons. We can avoid, nullify the emissions from biogas engine at the local scale because we can inject biomethane into the grid. We can increase overall energy efficiency. Let's think about the electricity efficiency of a gas turbine, 58%, compared to a biogas engine that doesn't recover thermal energy. And the third reason is that we can use it as a vehicle fuel in a country, Italy, that has the highest number of gas vehicles and the large shortage of gas stations. Most of all, biomethane can cover up to 8% of Italian consumption. So it can be a strategic, internal, virtually everlasting source. Biogas upgrading techniques involves environmental impacts as well. For example, methane losses, and that should be minimized. But it is again a matter of regulation, of rules, of subsidies that should push towards the sustainability of any process solutions. Let's go back to the problem of nitrates and the problem of ineffective fertilization. Here you can see a balance for nitrogen done for a rural area like the province of Cuneo, but it can be exported to any province in northern Italy, to Parma, Cremona, Verona, Padova, and so on. Here you can see that just 50% of nitrogen produced by livestock or coming from chemical fertilizers goes to the target, that is, become vegetal protein. The remaining part is volatilized as ammonia. You can see from the satellite the spot of ammonia, or is leached towards the groundwater, and this is the situation of nitrate contamination. And the reason is that a good management of manure, of digested materials, needs low volumes and high solid content. So we have to concentrate materials to have good fertilization. And we can do that in many ways. We can do composting, we can do stripping, we can use dryers, we can use under vacuum evaporators using heat and powers produced by the biogas engine. This is an example, I reported an example of how we can solve two problems at the same time. That is the post-methanation phenomena, the production of residual biogas from digested materials during the storage, and ammonia volatilization during the same phase. We can use biogas to strip, to desorb ammonia, and then we can wash it with sulfuric acid to produce a concentrate fertilizer, ammonium sulfate, 30% in concentration. And then we can deliver biogas to the engine or to the upgrading plant as well. This kind of plant can reach very high ammonia removal efficiency from 20 to 40 to 50% according to the different pH and temperature conditions. But all energy required, heat and power, can be covered by the residual recovered biogas energy. So it is sustainable. So the third and last part of the speech will be dedicated to a big and unsolved problem, that is odor impact coming from any kind of plant, not only from waste treatment or disposal plant, but also from animal byproducts plant, chemical plants, also food production plant. The hardest obstacle for everyone is that in Italy we don't have a specific regulation, specific limits for this kind of stuff. We just have regional and national guidelines describing how to collect emissions, how to reduce emissions, how to sample and analyze odors, how to predict the impact of odors at the ground level, how to assess whether this impact is acceptable or not, and so on. So the description of the general strategies to reduce the odor impact below the acceptability threshold is not easy, but some rough design mistakes should be avoided. The first aspect is the collection of emissions. The highest the air changes per hour, the largest the odor reduction efficiency, of course. But the design of the collection system should be made carefully in order to avoid that even very small areas, volumes of the plant are pressurized and not depressurized. For example, where we blow air under the composting area, these volumes can be pressurized and not depressurized. A second aspect is the stack design that is always undervalued, but a good exit velocity that is 15 meters per second, a good exit velocity can ensure a good dilution and dispersion of pollutants into the atmosphere with abatement efficiencies that could be larger than specific abatement device efficiencies. And then the last point is most of odorous phenomena comes from open sources that should be reduced as far as I can, of course. Then we could talk about abatement devices for hours. It would be challenging, of course, but we don't have the time. Just a mention on anaerobic digestion as pretreatment. It's very useful to reduce the easily biodegradable compounds that could be desorbed during the composting, during the aerobic process. And many composting plants are going towards this direction with good results. Of course, the best technique is to match both the strategies. And an example of these combined strategies is these two slides. On the left, you can see the odor concentration coming from a very good abatement device that is the biofilter, but it is an open biofilter with a very low exit velocity of the waste gas, and this is the impact at the ground level of odor. On the left, the same odor fluxes, but treated in a closed biofilter with a stack, with a plume rise, and the impact at the ground level is reduced by 1 order of magnitude. So, of course, we have to pay more to push waste gas to the stack, but when we have long period of atmospheric stability and inversion phenomena, in this case you have the best possible dilution. It could be very important to reduce the nuisance. So let's go to conclusion. We learn an important lesson, that is that renewable energy sources and biological treatment could involve environmental burdens that are very important in delicate regions such as northern Italy. The solution is, of course, and always technology. And technology is ready to ensure the maximization of efficiency and minimization of impacts, but technology should be stimulated by rules, by regulations, by subsidies. And so far, strong economic subsidy, mainly based on electricity production, has been totally unfit to lead a sustainable development of the sector, in my opinion. A good subsidy should be linked to avoided CO2 emissions, avoided ammonia emission, avoided NOx emission, and so on, to be environmentally consistent and sound. Just a quick overview of new and changing regulation. The region, Piemonte, has provided the authorizing administrations with guidelines and planning regulation that reports many of the sustainability criteria that we mentioned in the present speech. So it's a good help, but unfortunately these sustainability criteria are not mandatory because regional competence cannot overlap national ones. So the problem is the national law, not the regional one. And the draft for the new Italian subsidy regulation talks about a feed-in tariff of 30 euros per megawatt hour for plants that remove 70% of nitrogen by using all thermal energy at disposal and producing a fertilizer. And this is the right direction, but the question is, isn't it too late for do that? Thank you.